Hey everyone, I hope you're doing well today. In this video, let's talk about solving different types of multi-step equations. If you're ready to start working with multi-step equations, I'm assuming that you're already able to work with one-step and two-step equations, and you also feel comfortable with simplifying expressions by combining like terms and using the distributive property. To solve the multi-step equations in this video, we're going to have to use all these concepts together. Let me show you the three types of multi-step equations that we're going to cover today. The first type of equation will deal with combining like terms, where we'll have to combine the like terms before we can solve the equation. The second type of equation that we'll also work with have to use the distributive property. In these examples, we'll have to distribute before we do anything else. And the third type of equation that you'll see has to deal with multiplying by reciprocals. In these types of equations, we'll talk about how you can avoid using the distributive property by multiplying both sides by a reciprocal of a fraction. Whether you just want to sit back and observe how I solve each of these equations, or you want to grab some paper and something to write with, either way, let's do some math together. In the rest of this video, we'll start by solving three equations where we have to combine like terms first, and then we're going to solve three equations where we have to use the distributive property, and finally we'll solve three equations where we have to multiply by the reciprocal. Let's get into it. For these first three examples, let's solve each of them by combining like terms first. For example 1, our two like terms are x and 2x, and remember that we do have a coefficient of 1 for this 1x over here to the left. Combining a positive 1x and a positive 2x together, we're going to get a positive 3x, and we can just copy this minus 3 and equal to 6. At this point, we just have a two-step equation now. We're going to go ahead and add 3 to both sides of the equation. And adding the 3 to the negative 3, we're going to get 0, so that's going to be 3x plus 0. And adding 3 to 6 on the other side, we're going to get 9. By the identity property, we can go ahead and drop that 0 and just say that 3x is equal to 9, or 3 times x is equal to 9. Then we're going to go ahead and use the division property of equality and divide both sides by 3, because this 3 and 3 will cross cancel to make a 1, which makes a coefficient of 1, and we can write 1 times x, or 1x, is equal to 9 divided by 3, which is 3. And finally, we can just go ahead and drop that 1 by the identity property of multiplication, and say that x is equal to 3. There's our solution. For number 2, let's see if we can spot our like terms here. It looks like we have a positive 12y and a positive 10y, and combining those together, we're going to get positive 22y. Going ahead and copying down the plus 14 and equal to 80, we now have a two-step equation. What we're going to do next is we're going to subtract 14 from both sides because we want to get 0, and then we'll try to get 1 in a little bit, but we'll start by subtracting 14 on both sides here. As planned, these opposites are going to create a 0, so we'll have 22y plus 0 on the left side of the equation. And on the right side of the equation, 80 minus 14 is going to equal 66. Dropping that 0, we can say 22y, or 22 times y, is equal to 66. So we're going to go ahead and divide both sides by 22. And when we do that, these 22s are going to cross cancel and make 1s. So we're left with 1 times y, or 1y on the left side. And on the right side, 66 divided by 22 is equal to 3. We don't really have to write that 1, even though it's there, and we can say that our solution is y is equal to 3. And here's one more example where we have to combine like terms first. First, we want to notice that 3w and minus 5w, or negative 5w, are like terms, and we can combine them. So we're going to leave this negative 2 alone on the left side, and 3w minus 5w is going to equal negative 2w. And we're going to have this minus 18 that's next to it. And let's see, to get 0 here, we're going to have to add 18, which is the opposite of that negative 18, or minus 18, and do that to both sides of the equation. On the left side, this negative 2 plus 18 is going to equal positive 16. And on the right side, we have this negative 2w. And when we combine that positive 18 with negative 18, we get 0. Of course, we can go ahead and drop that 0 and say that 16 is equal to negative 2 times w. And to get a coefficient of 1 for w, we can go ahead and divide both sides by negative 2. And on the left side, that 16 divided by negative 2 is going to equal negative 8. And on the right side, this negative 2 over negative 2, or anything over itself, is just 1, so we'll have 1 times w, or 1w. Finally, we can drop that 1, and if we want to, we can turn this around as well and say that w is equal to negative 8. There's our solution. And there you have three quick examples of solving equations where you combine like terms first. For questions 4, 5, and 6, let's make sure we use the distributive property first before we do anything else. So we're going to distribute this 2 to each of the terms on the inside, which means we're going to multiply it by both of them. And so we have this 14 out in front. 2 times that 4x is going to be a positive 8x since they're both positive. And then 2 times the minus 3 or the negative 3 is going to be a negative 6. We could write plus a negative 6 or just minus 6, and that's equal to 40 on the right side. At this point, this equation should look a little bit like the examples 1 through 3, where we have to combine like terms. 14 minus 6 is going to be 8, so let's go ahead and keep that 8x. We didn't do anything with that. And we have this plus 8 for the constants that we just combined, and that's equal to the 40 on the right side. Now our goal is going to be to get 0, and we can do that by subtracting 8 on both sides of the equation. On the left side, by subtracting 8, we get 8x plus 0. And on the right side, 40 minus 8 is going to equal 32. We can drop the 0 as we have been doing in previous examples, and we have 8x is equal to 32. So 8 times something is equal to 32, so the opposite operation is going to be dividing by 8, or the inverse operation. And this 8 over 8 is going to give us the 1 we're looking for as a coefficient. So we have 1x, or 1 times x, is equal to, and 32 divided by 8 is equal to 4. And finally, we can go ahead and drop that 1 by the identity property and say that our solution is x is equal to 4. For example 5, you want to be a little bit more careful because of this negative 3 that we see in front of the parentheses. So we're not distributing a positive 3, we're distributing a negative 3 instead. So let's go ahead and keep that 27 on the left side, leave that alone for now. Leave alone this 3y, just copy it down. Negative 3 times positive 6 is going to be a negative 18. And this negative 3 times a negative 2y is going to equal a positive 6y. At this point, it's important to notice that we have some like terms of positive 3y and positive 6y. We can combine those to make a positive 9y. So we have 27 is equal to 9y minus 18. And let's go ahead and get 0 and get 1. So we can get 0 by adding 18 to both sides of the equation, just like that. On the left, 27 plus 18 is going to equal 45. So we're going to have 45 is equal to. And on the right side, that negative 18 and positive 18 cancel out, so we have 9y plus 0. And we can go ahead and drop that 0 and say 45 is equal to 9 times some number y. And to get the coefficient of y to be 1 instead of 9, let's go ahead and divide both sides by 9 here. The 45 divided by 9 on the left is going to equal 5. And the 9 over 9 on the right side is going to be canceling out and making 1. So we have 1y, or 1 times y. And if we want to turn it around and drop that 1, feel free to go ahead and do so, so we know that y is equal to 5. That would be our solution here. For number 6, let's try one more where we're going to have to distribute a negative number, because I know that can be a little bit confusing sometimes and hard to keep track of all the signs. So let's go ahead and see. This negative 3 is going to stay the same, and we have this 12w, and a negative 5 times a positive 2 is going to be a negative 10, so we can write minus 10w. And this minus 5 times a minus 7, or negative 5 times negative 7, is going to equal a positive 35. We have a couple of like terms here, this 12w and this negative 10w. We can combine those to make 2w. So we'll have negative 3 is equal to a positive 2w plus 35. And to solve for this w, we're going to have to go ahead and get 0 first and get rid of the constant of plus 35 by doing the opposite, or the inverse, and subtract 35 from both sides here. On the left, this negative 3 minus 35 is going to equal a negative 38. And on the right, we have this 2w, and those are going to cancel out, and we're going to say that's plus 0. We can go ahead and drop the plus 0 and say negative 38 is equal to 2 times some number w. And to get a coefficient of 1 for w, or to solve for 1w, we can go ahead and divide both sides by this positive 2. On the left, half of negative 38 is going to be a negative 19. And on the right side, this 2 over 2, as with all the other examples, are going to cancel out to make 1. So we're going to have 1w alone on the right side, and we can go ahead and drop that 1 and say that w is equal to negative 19. There's our solution. And there you have 3 different examples where you have to use the distributive property first, then combine like terms, and then solve a 2-step equation. So for these last 3 examples, let's try solving these multi-step equations by using the concept of reciprocals. While your first instinct might be to distribute each of these fractions to what's inside the parentheses, we actually don't have to. Let's take a look at number 7 here. Instead of our first step being to multiply this 4/3 to each of these terms inside here and dealing with thirds throughout the equation, What we can do instead is multiply both sides of this equation by the reciprocal, or 3/4. When we do this, these 3's are going to cancel out to be 1's, and these 4's are also going to cross out to be 1's as well. That leaves the left side of the equation as 1 times the quantity of this 7 minus x. And on the right side of the equation, we have 12, or 12 over 1, multiplied by this 3 over 4. On the left side, you can either drop the 1 or distribute it, but everything's going to stay the same. It's going to be 7 minus x. And on the right side, when we multiply these fractions, turns out we can cross cancel this 4 and 12 to make 3 and 1. And 3 times 3 is going to be 9, and 1 times 1 is 1 on bottom, so 9 over 1 is just going to equal 9. So now we have a two-step equation, and to solve this, let's go ahead and try to isolate x, and first we're going to subtract 7 from both sides. On the left side, 7 minus 7 is going to be 0, so we'll have 0 minus x. And on the right side, 9 minus 7 is going to equal 2. We can go ahead and drop that 0, and we have negative x is equal to 2. And just don't forget that we actually do have a coefficient of a negative 1 in front of this x, so in order to get that coefficient to be a positive 1, we can divide both sides by negative 1, or we could have multiplied both sides by negative 1, either one is fine, and we'll get a positive 1x, or just x, is equal to negative 2. There's our solution. Now let's take a look at number 8. Instead of distributing this 8/7 to this 3y and negative 1, and then deal with adding and subtracting fractions with sevenths, let's instead multiply both sides of the equation by the reciprocal of 8/7, which is going to be 7/8. On the left side, I'm just going to rewrite this so it's a little bit easier to work with. So the 7/8 is going to multiply by this negative 32, which is negative 32 over 1. And on the right side, notice how these 8's are going to cross cancel to be 1's, and these 7's are going to cross cancel to be 1's as well. So we really are left with this 1 times the quantity of this 3y minus 1. On the left side of the equation, notice how we can cross cancel this 8 and 32 to make a 1 and a negative 4, and 7 times negative 4 is going to be a negative 28 over 1, or just negative 28. And on the right side, you can either distribute that 1, which doesn't change anything, or we can just drop it and say that 3y minus 1 is what we're left with. Now we have a two-step equation. We can go ahead and add 1 to both sides. Negative 28 plus 1 is going to be a negative 27 on the left. And on the right side, this negative 1 and positive 1 will combine to make a 0. Then we can go ahead and drop that because it's not really necessary by the identity property. We have negative 27 is equal to 3y, or 3 times y. And to get rid of that 3, to get a coefficient of 1, we can go ahead and divide both sides by 3. And negative 27 divided by 3 is going to be negative 9. And we'll have 3 divided by 3. These will cross cancel to make 1, so we have 1 times the y, or just 1y. And we can drop that 1 again and say y is equal to negative 9. That will be our solution. And just for good measure, let's try one more just to make sure you got it. So for number 9, we totally could distribute this 2/5 to both of these, but then we'd have to deal with fifths the entire time. But instead, let's go ahead and multiply both sides by 5/2, which is the reciprocal of 2/5. And rewriting this left side with fractions, I'll say 5 over 2 multiplied by this negative 14 over 1. And on the right side of the equation, just as we planned, these 2's are going to cross cancel to make 1's, and these 5's are going to cross cancel to make 1's. So we have 1 times the quantity of this 9 minus 2w. On the left side, this 2 and negative 14 will cross cancel to make a 1 and a negative 7. And 5 times the negative 7 is going to be negative 35 over 1, or just negative 35. And on the right side, we can just go ahead and drop that 1 and say it's 9 minus 2w. At this point, we have a two-step equation, so let's go ahead and try to isolate that w. And to first do that, we have to subtract both sides by 9. Negative 35 minus 9 is going to be negative 44 on the left side. And on the right side, 9 minus 9 is going to equal 0, so we have 0 minus the 2w. And we can drop that 0 and just say that's negative 44 is equal to negative 2 times w. And to get rid of this negative 2 and to get a coefficient of positive 1, go ahead and divide both sides by negative 2. On the left side, negative 44 divided by negative 2 is a positive 22. And on the right side, that negative 2 over negative 2 will cancel out to make 1's. So we have 1 times w, or just 1w. And if we know that 22 is equal to 1w, then w should equal positive 22 here. There's our solution. Hopefully at this point, you now feel a little bit more comfortable with dealing with these types of multi-step equations. Remember, the first three examples dealt with equations where we combine like terms before we do things to both sides of the equation. The next three examples after that, examples 4 through 6, dealt with distributing before we solved a two-step equation. And then when we got to examples 7 through 9, instead of distributing a fraction, we multiplied both sides of the equation by reciprocals so we could avoid that whole mess of dealing with fractions throughout the entire problem. If you found this video helpful, please let me know in the comment section down below and give this video a thumbs up. And as always, keep up the great work, and I'll see you in the next one.